No, start. Okay then. So when we talk about reduced instruction set, it is an important aspect of computer architecture. Okay, it is designed for instruction set in the processor. Okay, see what is the purpose of reduced instruction set computer? Because there are a lot of complex instructions that are given in the earlier stages, so it takes a lot of time and the time complexity also increased so much. So because of that we have reached to this reduced instruction set computer, where we are going to talk about the instructions which are reduced and how the process is going to be worked. So the first thing we would like to talk about, it is an important aspect of computer architecture which is designed for instruction set for the processor. And instruction set is chosen for a particular computer which determines the way the machine language programs are constructed. It means it depends on particular computer and which determines the machine language. Okay, a machine language programs are constructed. So many computers have instruction sets. Okay, many computers have instruction sets that include more than 100, and some systems might have more than 200 instructions even. So based on the system, based on the computer system that we have, it depends on the system that we will be having an instructions. Okay, many computers, that means many computers we are having different kinds, different lengths of instructions. Some computers might require 100 instructions to complete the same task, and some systems, some machines might require more than 100, 200 instructions in order to complete that task. So these computers also employ a variety of data types. Okay, these computers also employ a variety of data types and large number of addressing modes. So we'll be having large different addressing modes access in order to access the data. So what do you mean by having different data types? It means the system should be able to understand the inputs that are given from input device. So there are lot many. Let us take an example. If you have integers we are having of different types. Integer numbers, floating values, decimal values, and all different. The system should be able to recognize which value that you are giving from input device. So we'll be having different data types and large number of addressing modes in order to address the data. So the trend into this hardware complexity was influenced by various factors. So the factor is that upgrading existing models to provide more customer applications. So we are upgrading existing models. So what already we have some models which are designed. So we'll be taking that existing models and we are improvising them in order to provide customer applications. Is it so? Yes. Are you able to follow me?
Yes, ma'am.
Yes, ma'am.
Yes. So here we are upgrading the existing models to improvise or to provide more computer customer applications. So customer satisfaction or customer requirements should be satisfied by a software engineer, right? So in order to satisfy a customer's requirements and all the complexities which should be reduced, for that we have to upgrade our systems. Okay, then adding instructions that facilitate the translation. Yes, by adding instructions, giving instructions to the computer for translation from high level language to a machine level language, which is lower level language. Okay, addressing instructions that that facilitate translation from high level language to a low level language, which is a machine language programs. Okay, in order to develop machines, okay, here in order to develop machines that functions from software implementation into a network implementation. Yes, network connections and all the everything depends on the instructions that you are giving. Suppose you have a Wi-Fi connection, you are instructing to connect only a 10 members. there will be a restriction. You will be providing an instruction to the network that you have to connect with only 10 devices only. The instructions that you are giving to a machine to communicate, to give connections. Getting? So we'll see the characteristics that we have for CISC characteristics and reduced instruction set characteristics. So we'll be discussing about these two now. A large number of instructions, which are typically from 100 to 250 instructions, are there in complex instruction set computer. And some instructions that perform a specialized task and are used infrequently. Okay, they are used infrequently. They are not used frequently for their daily purposes in order when you are performing, when you are coding or when you are doing some actions on a system. So large number of variety of addressing modes, typically from 5 to 20 different modes. Getting? So here the addressing modes will be, when we talk about instructions, it is from 100 to 250 instructions. And when we talk about addressing modes, that they are going to be from 5 to 20 different modes. Okay, the variable length instruction formats. So now in this, the variable instruction formats also be matters. In this also it matters here. And instructions that manipulate operands in the memory. These are all the different characteristics that are performed in complex instruction set computer. And then when we move on to the next thing, that is reduced instruction set characteristics. Here, the concept of reduced, that is RISC architecture, involves to attempt to reduce the execution time by simplifying instruction set of the computer. Is that so? Are we going for RISC characteristics, RISC procedure for to reduce execution time? The main purpose of using this reduced instruction set computer is for reducing the execution time. Okay. For that, in order to achieve this goal, what are the different characteristics that we have to follow? Are relatively few instructions we need to have, first point, and then we need to have relatively less or few addressing modes, and then memory access should be limited to load and store instructions. Yes, in order to getting filling up the memory, so either by loading or storing instructions should be limited. It should not be we should not allow to download or to store the data whatever it is giving. So there should be limitations to give more performance of this for the system. All operations done within the registers of CPU. Yes, all the operations done within the registers of CPU. Registers contain CPU contains what? Registers, right? In order to store the data. So all the operations should be done within the registers in a computer. So there will be some fixed length, easily decoded instruction format, and single cycle instruction execution. Single cycle at a time. It should not go for multiple formats in order to complete one task. So it is going to be performed in one single cycle for the execution, hardwired rather than microprogrammed control. Okay, these are the different RISC characteristics in order to achieve our goal is that to reduce execution time. So these are the different characteristics that we have to follow. And then we talk about the next topic that is in 50 unit is pipeline and vector processing. Okay. Just wait. Now look at this screen. Here we'll be talking about pipeline and vector processing. Are you able to see this picture?
Yes, ma'am.
Yes. So, in this pipeline and vector processing, we'll be discussing about different elements. Okay. What are those elements? I'll tell you. First thing we'll be talking about parallel processing. Secondly, we'll be talking about the pipelining. And third, we are going to talk about arithmetic pipeline and instruction pipeline, risk pipeline, vector processing, and array processors. Okay. These are the 7 different elements that we are going to discuss in the second part of 5th unit, which is pipeline and vector processing. Okay. Getting my point? Now we'll start with the parallel processing. Here in the parallel processing, this is a term which is used to denote a large class of techniques. Okay. Which is used for, which donates a large class of techniques that are used to provide simultaneous data processing techniques. Yes. Parallel processing means what? Parallelly working. Parallelly 2 techniques working, 3 techniques working, like that. Parallelly at a time. Parallel processing is a term used to donate large class of techniques. Large class of techniques that are used to provide simultaneous data processing tasks for purpose of increasing the computational speed. What is the purpose of using this? The purpose of using this parallel processing is to increase the computational speed of the computer system. Yes? And the purpose of parallel processing is to speed up the computer processing capability. Getting? We need to speed up the computer processing capability and increase its throughput. What do you mean by throughput? Yes? Throughput means the amount of processing that can be accomplished during a given interval of time. Getting? Throughput is the amount of processing. The amount of processing any task. Processing amount of processing that can be accomplished during a given interval of time. Within the time period, if you are able to complete the task, then that we are saying a throughput. Okay. The main purpose of parallel processing is to speed up the computer processing capability and increase its throughput. Our goal is to increase the capability and increase its throughput. How we can increase the throughput? Before that, what is throughput we should know, right? Throughput is about the amount of processing that can be accomplished during a given interval of time. Okay. Then a parallel processing is established by distributing the data among the multiple functional units. Is it so? Is this the purpose of using parallel processing? What we are saying, parallel processing is established by distributing the data among the multiple functional units. The sequence of instructions which are read from memory constitutes an instruction stream. Yes, the sequence of instructions which are read from the memory that constitutes an instruction stream, and the operations which are performed on those instructions, data, the operations which are performed on the data in the processor constitute data stream. You need to understand here 2 points. One is what is instruction stream and the other one is data stream. What is the purpose? What do you mean by those 2 words? The first one, instruction stream, is for instructing the sequence of instructions which are read from the memory, that we are calling it as instruction stream, and the operations performed on the data, okay, that in processor, okay, the operations performed on data in processor which constitute data stream. Okay, parallel processing may occur in both any of the cases. It might be an instruction stream or a data stream, or it can be of both. Yes. And then we'll move on to the next topic, which is Flynn's classification. Okay. flying's classification, which divides computer into 4 major groups as follows. See, here we'll be discussing about 4 different flying's classifications. If you are, if suppose you get a question like define or what are the flying classification in a computer, then you should be able to write these 4 different groups. Okay, what are those? Single instruction stream and single data stream. Okay, when you have a single instruction and single data stream, which is 1 to 1. Do you all know this, right? Discrete mathematics, you'll be learning, you might be learning about this. 1 to 1 mapping, 1 to multiple, 1 to many mapping, many to 1 mapping, or many to many. Same concept, same concept. Here you are going to see here. See, single instruction stream and single data stream. Second, we are going to discuss about single instruction with multiple data streams, how it is going to be performed. And if you go for multiple instruction stream and single data stream. And the third one is multiple instruction stream and multiple data stream. Getting? So look at here, single instruction stream and single data stream, right? It represents the organization of single computer consisting of a control unit, a processor unit, and a memory unit, which contains what? SISD represents an organization. It is an organization, okay, of a single computer containing what it contains? It contains a control unit, a processor unit, and a memory unit. Yes. So we'll be running out of time. So after this session, you again rejoin. Okay. In a very simple example, you all have a database management system like DBS subject, right? Have you all gone through that subject? Yes. I couldn't able to hear anyone. Do you all know about the database management system subject? Yes. Yes. Are you all able to hear me?
Yes, ma'am.
Am I audible?
We don't have DBMS subject, ma'am, but we have topic of.
Okay. Okay, then fine. So let us take a small example. Okay. Here there is a vehicle and a single patient. Okay. Single vehicle and a single patient databases. Okay. You have 2 tables. Okay. One is for storing the data or about the vehicles that a hospital providing, and the patients in another table. If you see a single vehicle and the patient, which maps both the tables, and with the tables we can see on which vehicle that patient has arrived to hospital. Okay. Simple. In a basic level, you try to understand what is a single instruction stream and a single data stream in a general purpose. In general purpose, how we can talk about these instructions. Okay, getting my point? Single instruction stream and a single data stream. Here the instructions are executed sequentially. Parallel processing is achieved by means of multiple functional units or by pipeline process. Okay. So what we are talking about is, see, if there is a vehicles table, number of vehicles and number of patients. So when we talk about 1 to 1, a single vehicle and a single patient arrived at that in that axis. Only those 2 data is available in our table. when we talk about single instruction stream and multiple data streams, which means we have a single vehicle and multiple patients. Getting? You are able to follow? Single instruction, multiple data streams, multiple data. Yes, all the processes here in the second part of this flying classification, which we are talking about, a single instruction stream and multiple data streams. Here it represents an organization that includes many processing units under common control unit, which is on single control unit processing on different processes. Getting? Only one system is admin. If you talk about college administration, a main administrative admin will be the admin will be there. He is responsible and he'll be giving all the authorities, all the restrictions to the different systems. Like if I am using I am the host of this lecture. Okay, so I am the host and I am going to restrict you in all the ways, like you should not able you could not able to talk in the middle, or you cannot share something, all the restrictions which I am giving. Yes, all the processors receive same instruction, but the control will be on one single system. Getting? SIMD, which represents an organization that includes many processors, many you people, many students, which is controlled by a common control unit, which is I am. I'm the control unit and you are different processors. Getting? All processors receive same instruction. Is it so? All you are able to hear only my voice, right? All processors receive same instruction but operate on different item of data. But operate on different. You are different from other. You all are different people, right? Different processors. I'm the common control unit. Yes, this is the second part of flying classification. And if when we on to this third part is multiple instruction stream and multiple single data stream. Theoretically, there is an article about multiple instruction stream and single data stream, but in a practically it has not constructed. Okay, so you can write in this way: MISD structure is only of theoretical interest. Okay, but there is no practical system has been constructed using the organization. So it is an idea that we can perform like this: multiple instructions, multiple control units like that, having a single data stream. But practically it has not implemented till now. Okay, so when we talk about the other last point, a multiple instruction stream with the multiple data streams. Okay, in this MIMD organization, which refers to a computer system capable of processing several programs at the same time. Most of the computer systems can be classified in this category. Okay, many vehicles, many patients. Anyone can access from any of the resources. Yes, and we'll show you what are multiple functional units in a processor. Okay. Yes, processor with the multiple functional units. See, this is a processor register, which is in a memory, okay, which is in memory device. This is a processor register, and these are the multiple functional units. Yes. So, what are the different multiple functional units? Are adding and subtracting, integer multiplications, logic unit, shift unit, incrementers, and floating points. Okay, floating point for multiplication. Here the floating point for addition and subtraction, and floating point for division. Yes. Yes, could you able to see this? This is a processor, and here these are all the different functional units which performed by the processor. Yes. Next. Next, our third part is pipelining, right? So the pipelining, when we talk about pipelining, it is a technique of decomposing a sequential of process. Pipelining is a technique of decomposing a sequential process into sub-operations, with each sub-process being executed in a special dedicated segment, okay, that operates concurrently with all other segments. Look at this example. Yes, suppose we want to perform a combined multiplication and addition operations in a single stream. Okay, you have an instruction. In that, you want to perform both multiplication and addition. Then this is how it going to be. Say AI into BI plus CI, which means for I equal to 1, 2, 3, 4, 5, 6, 7, so on. Okay. Each sub operation, these are operations, right? Multiplication and addition. Each sub operation is implemented in a segment within a pipeline. Okay. Each sub operation is implemented in a segment within a pipeline. What do you call a segment? Each segment has one or two